My name is Naol Ketema, and this is my DAC, or a digital to analog conversion. Through the R2R ladder, digital inputs are converted into analog outputs. This is the functional breadboard prototype of the R2R ladder. As you can see, in this functioning breadboard prototype of the R2R DAC, there is the use of a 9-volt battery, an LM741 op-amp chip, a 5mm red LED, an 8-position DIP rocker switch bank, a bus resistor, 7 5.1K fixed resistors, and 9 10.2K ohm fixed resistors. As you can see, the leftmost switch on the switch bank is turned on, and that is the least significant bit. When we measure the voltage contribution of the least significant bit, that calculates to 8.6 times 1 over 256, which is about 0.033. And what we're getting, as you can see, is 0.04, which makes it accurate. We can measure each individual switches or bit's voltage contribution. This is the application of the superposition theorem. This theory states that in a linear system, the output caused by multiple inputs is equal to the sum of outputs of each of the individual inputs. In addition to the actual measurements that are presented, this calculation can be done to see the approximate voltage contribution of each switch or bit in this case. Although not functioning, the printed circuit board prototype of the R2R DAC uses a custom PCB, a 2.1mm DC power jack, an op-amp chip seat, a 4-position header right angle that is through hole, a surface mount yellow LED, a surface mount 103 capacitor, a bus resistor, 4 screws, 4 brass inserts, and the 2 sets of fixed resistors, the 5.1K ohm fixed resistors and the 10.2K ohm fixed resistors. A key concept in the R2R DAC is the Thevenin theorem by Leon Charles Thevenin, which states that it is possible to interrupt a circuit anywhere as long as it only contains linear elements such as resistors, voltage, and current sources, and replace the resistors and voltage sources with a single voltage source and resistors. For example, these two 2Rs are in parallel, and we know that that can be simplified to an R because 2 resistors in parallel with the same value can be simplified to half of the resistor value of one of the resistors. In this case, it simplifies to R. The 2 resistors R and R are in series, meaning addition, and they become 2R. Then this process repeats over and over again until the output resistance and the only thing that's left is just R. This is the application of the Thevenin theorem, and it is crucial in circuit analysis. Digital to analog conversion devices are especially used in high-end audio equipment in order to alter digital signals to be smooth-sounding analog signals, such as the ones used in your AirPods. I hope you learned something regarding the R2R DAC.